Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome to this presentation for our pneumatic and hydraulic uh, explanation. So in this module, in the third module, I'm going to discuss the control of a double acting pneumatic cylinder using limit switch and a timer integrated into a PLC header program. First of all, my name is Genta Sentosa with ID student 123490009 from Instrumentation and Automation Engineering. So we will see from this slide for the material. So the main focus of today's discussion is how we combine a pneumatic actuator, which is the double acting cylinder with electrical control through limit switches and timer, and then implement the logic using a PLC ladder program, a diagram. Sorry. This session is very important because it gives us hands-on experience in connecting physical pneumatic components with programmable logic controllers, which are widely used in modern automation and industrial systems. Okay, we will continue to the second slide. On the second slide is the objectives of the practical. So the objectives of this practical are quite clear and structured. By the end of this module, we are expected to understand these five objectives. So we will hopefully understand the working principle of a double acting pneumatic cylinder in a electro-pneumatic system. We learn the function and role of the limit switch as a position sensor for the pneumatic actuator. We design and analyze an on-off control circuit for the pneumatic cylinder by integrating the limit switch and timer. And then hopefully we will learn to implement the control circuit using a PLC ladder diagram based on the basic principle of the electro-pneumatic control, and identify the relationship between the pneumatic system, the sensor, and the logic control in simple industrial application. So all these objectives may sound simple, but each of them represent a step in bridging mechanical movement, sensing, and programmable logic into one integrated control system. So we will next to the third slide. By the way, I got this slide from my practical assistant. So, and then we continue to the third slide. The third slide is general question. The general question, the general guiding question for this model is, how does a limit switch detect the position of cylinder? So this is a fundamental question because in automation, detecting the exact position of an actuator is critical for sequence control. The limit switch is a mechanical sensor that changes its state when a physical object, such as the piston rod of a cylinder, comes into contact with it. When the cylinder extends or retracts, the limit switch will either close or open its electrical contacts, sending a signal to the PLC. So this simple mechanism is extremely powerful. It allows us to synchronize pneumatic motion with logical decision making in the PLC program. For example, when the piston reaches its extended position, the PLC can trigger a timer delay for a certain period and then command the piston to retract. So this question about the limit switch actually opens the door to understanding the entire control of process. So we will next to the fourth slide. This is the ladder PLC. So this is the ladder PLC diagram. We will use CX programmer. So In CX programmer, the ladder diagram is our main programming environment. It uses graphical symbols that resemble relay logic, make it easier to visualize the control flow. For this practical, our ladder diagram involves input from the limit switch. I will close it up for you guys. Okay, you can see clearly now. And then uh, for this practical, uh, the ladder diagram involves input from the limit switch, a timer decision, a timer instruction, and output that control the solenoid valves connected to the double acting cylinder. The ladder diagram represents logical condition. When the conditions are satisfied, the PLC energizes the corresponding coil, which could be the output solenoid. So, in simple terms, limit switch and then goes to PLC input and then next to logic in ladder diagram and then continue to PLC output, go to solenoid valve and then the cylinder movement. So that is the simple terms of this practical. And then we will continue to the fifth slide. Okay, so this is the ladder PLC, the design step. So we will go deeper into the design. We will define input and outputs. In input, limit switch, uh, the first limit switch is for the extended position. The second limit switch is for the retracted position and start button. So there are three input, the two switch and one button. And for the output, there are solenoid A to extend the cylinder and solenoid B to retract the cylinder. And insert timer in the ladder diagram. After the cylinder extends fully and activates limit switch 1, the PLC starts the timer. The timer waits for a preset duration, for example 5 seconds. After after the timer expires, the cylinder retracts, so it will go back to its own form. Interlock the sequence. When the cylinder is retracting, it should not extend again unless commanded by the start button. Okay, so it will not move if we didn't press the button. This ensures the sequence runs smoothly and avoid conflict between solenoid A and B. In CX programmer, you create contact for the limit switch, uses the TIM instruction for the timer, and place coils for the outputs. This way, you can simulate and test the logic before running it on the physical trainer board. And then I think that's all for the slides. Maybe I will continue to demonstrate the PLC and pneumatics diagram on the CX programmer. Okay, we will try to follow this diagram. So I will open CX programmer and then we can click, we can make a new file. You can name it whatever you want. I will name it header PLC. And then for the device side, I will use CP1L and then OK. And then we will follow the diagram from the slide. We will just make it. I will explain the diagram after I finish the diagram. So we will focus to finish the diagram first, and then I will explain the diagram after that. Okay. Okay. Comment. Write a comment. Okay, I will close it up. And then okay. Okay. Mm. Okay, so I have finished for the diagram in CX Programmer, and now I will explain to you about the diagram. So to make this diagram, first of all, you can make a new file just like I show you. Okay, so in this diagram, there are input on and off contact. So we can see to contact level 0.00 and 0.01. This is marked as on and off. So this represents the input condition. For the example, they could be connected to push button or limit switches. So when the on contact is activated, it allows current flow in the logic. The off contact works in the opposite way. It prevents current flow unless the condition is false. So it's like the logical gate. And then there are timer instruction T000. So in the middle of the rung, there is a box labeled T0000 with a description timer Pneumatik. So 5-second timer. This is a timer instruction or TIM in CX programmer. It is configured as TIM000. Uh, it means the timer counts in units of 100 milliseconds because yeah, like this. So when the input condition becomes true, the timer will start counting after 5 seconds. The timer finish and activates the output. And then there are output coil. So on the right side of the first rung, we have a coil label W0.000. This represents an output relay or coil. When the timer completes, this coil will be energized. In real hardware, this could be mapped to a solenoid valve controlling the extension of the pneumatic cylinder. And then we continue to the second rung. This is a limit switch condition. So on the second rung, we see that the W0.00 again used as an input condition. This means the second rung only works if the first coil is active. Then we have another contact level 0.02 limit, which represents the limit switch feedback from the cylinder. So this rung ensures the system recognizes when the cylinder has reached its limit position. And there is output coil 100.07. So yeah, like that. Finally, in the second rung, there are coil level 100.07 output. This coil represents another output, for example, the retract solenoid of the cylinder. When the limit switch is triggered and the conditions are satisfied, this coil is energized, causing the cylinder to retract. Overall function of the program is like this. So yeah, like that. Uh, Maybe that's all that I could tell you about the explanation. So uh, These concepts are directly applicable accessible to many industrial automation systems, such as packaging machine, robotic arms, and conveyor system, where precision, motion, and timing are essential. So I think that's all that I could tell you about the ladder diagram explanation. Thank you for your attention and thank you for watching. I hope this explanation and demonstration give you a clear understanding of the third module. Thank you. Assalamualaikum warahmatullahi wabarakatuh.